Nice to have you.
Hello.
Welcome.
Welcome.
So, gentlemen, first of all, great to have you with us. How are you feeling today?
Great.
Great?
Yeah.
Yeah, had a good day so far?
Impressive customer show up.
Yeah, huh? You've been here since yesterday, and when did you get in?
I got in relatively early yesterday morning.
Okay. And you're going to be here the whole week also?
Not tomorrow.
All right. All right. I'm going to start off with the first question, or maybe I should introduce these two. John heads the distribution energy solution business at Siemens Smart Infrastructure and knows exactly what possibilities innovative business models based on new technologies can offer. And then we have Willi Meixner, and Willi is responsible for developing plants and technologies at Siemens Gas and Power. And I'm going to start off with the first question. And delivering them, of course. I'm going to start off with the first question to John. I'd be interested in knowing how the possibilities of a distributed or local energy solution can change industrial companies.
Right. Well, it allows you to take control of your life cycle costs. Predictability of cost, reliability of supply, resiliency. And one of the examples we had was a beverage manufacturer in South America where they actually didn't care if it was a cent or two more on the power costs, but whenever they lost power, they had to flush out all the pipes and basically reset the factory. So it's a major impact to their business.
Right.
So that's just one of the examples of how you can take control of all aspects besides just the cost side, as well as your CO2 output, your impact on the environment.
So how do these business models for we call it a distributed energy solutions transformation look like?
Right. Well, I mean, it really depends on the need. So it's how much of your CapEx you want to convert to OpEx, how important is that to you? It can vary from a simple power purchase agreement to anything as complex as a multifaceted, multi-year implementation of a performance savings contract where we guarantee the performance savings that we would deliver to a client, reducing demand and improving supply, or even guarantee performance of a full system.
Okay. Now, my next question would be, how could customers take advantage of these regulations?
Right.
What regulations are we talking about?
Well, I mean, so you have tax investments credits for different renewables.
Right.
It depends country by country.
Right.
Some of the other things that it can actually give you a competitive advantage. So an example for a customer that we had, an industrial customer here in Germany, is the grid fees can have a significant impact on your business costs. And we implemented a system that would allow to eliminate their demand peaks that they were seeing, and they paid a massive grid fee. So by putting in a system that had battery storage, 2 CHP units, load shedding, highly efficient transformers and switchgear like Beatrix just mentioned, we were able to eliminate those peaks and reduce their grid fees by over 2 million euros a year. And that's for a 5 million investment, so it's pretty good ROI. And that gives them a competitive advantage on their costs for their product.
That is crazy. There's so much potential. What role does digitalization play here? And do you think, I mean, when you're talking about savings and efficiency,
right,
is this just the beginning? I mean, can we go even deeper into that?
It really is. I mean, what we do is when we work with a client, we start off with simulating the system that they have. First, we would look at what's their demand, what are some of the facility improvement measures we could take to reduce how much energy they're consuming,
right,
and then look at what's the right supply side system we can create that meets their goals: CO2 reduction, power, resiliency, reliability, and simulate that system digitally. And then when we implement that system, we can look at the performance, also digitally, remotely monitoring it to see that it performs as simulated, as well as use new technologies as we monitor the performance of the facility to offer some new digital services for them as the years go by.
So could you give us some concrete examples?
Sure.
These services?
Yeah, we had actually a hybrid plant in the Galapagos Islands, so pretty remote.
Okay.
And it's a zero fossil fuel approach. There's battery storage, there's solar, there's biodiesel on there, and we simulated it completely digitally. Obviously, the on-site costs are pretty high logistically, and it performed perfectly on the first installation, which isn't always the case.
Right.
And now we are monitoring it remotely from one of our Mines for Application centers in the Americas, looking at the performance, and it's performing about 98% accuracy with what we initially simulated. And we're improving that with technology to measure cloud cover for solar, et cetera. And it's an iterative loop of improving the simulations, looking at the performance, and adding those technologies.
Wow, that's fantastic.
Yeah, it's pretty cool.
That's and once again, I mean, this is just, this is basically just not what we can say the beginning, but I wonder how far can that go? I mean, you keep digging into, continuously optimizing all of these processes, and there's always something else you can find where you can say, hey, there's a knob we can turn, there's a little switch we could, maybe flip and change the game again, right?
Yeah, it's the compounding impact of all these small tweaks you can take by really getting transparency on what your system's doing.
That sounds fantastic. I'd like to address the next question to Mr. Meixner. When it comes to reliable power supplies and process heat, combined cycle power plants quickly come to mind. What does the trend towards decentralized energy systems mean for industrial turbines?
Well, our customers are clearly convinced that fossil-fired combined cycle power plants are next best to renewables. That's like you introduced.
Okay.
And what we see globally is a clear trend to individual applications. And let me give you a few examples there, what we see in the global marketplace. A country like Thailand has standardized on 150 megawatt combined heat and power solution for their industrial parks, which is today one of our largest decentral fleets we have installed over the last decade out there. Countries like Panama, where space is confined, are going to floating platforms. So many individual solutions which are required by customers and industries to really have a competitive decentral power and heat generation. Mm-hmm. What we also see as a coming trend is industrial sites converting from coal-fired to gas-fired power plants. So
really? Yeah.
In particular, also here in Germany, we see many of our customers applying these technologies. And what that means for us together with the customers is really interfacing to transform an existing infrastructure into a modern, decentral power and heat generating infrastructure with all its challenges if you go into brownfield. And their offerings like digital solutions, what we say here, become more and more prominent.
So what are the advantages that the, let's say, gas turbine technology has to offer?
Well, it's leading on fuel efficiency. If you look at a modern combined cycle power plant where you have power and heat, you have a fuel efficiency of 85%. Comparing that to the car industry, which is a lot in the media, they are at best at half of that. 35 to 45%. So you get twice as much usage of the kilogram of fossil fuel used, and twice of mass usage also of the emissions you produce than by any other means of power conversion today.
Are people aware of that?
Let's ask
I don't know. It's interesting. I think that's super interesting.
Yeah, it's
any other advantages you can point out?
Well, and leading on from these low emissions, next to renewables, it's flexible, it's easily to be deployed globally, and the infrastructure is there. So pipelines are nowadays available almost all around the globe, and with the increasing amount of LNG, gas is really becoming available to everyone.
Right. Okay. So how can gas turbine technology help make electricity and heat supply become more climate friendly besides the emission savings you just mentioned?
Yeah. Well, we are convinced that in order to transform our society into a fossil-free environment over the next decades, we won't be able to afford rebuilding complete infrastructures for the primary power, which is going to be renewables, and everybody knows that it's intermitting, and the backup power, which we will need, especially for our industrial sites. So the gas network and the gas infrastructure, which is available around the globe, from pipelines, from storage stations, from combined cycle power plants, is what we are convinced will bring us the future, because this infrastructure can be converted from fossil fuels step by step into biofuels, syngas, or hydrogen.
So basically, by using the existing infrastructure and not having to bring up, I don't know, energy and resources to put up an entire new infrastructure.
Exactly.
That is where the saving comes into play.
Yeah.
Kind of okay. Yeah. So that sounds exciting and promising. Of course, have you already concrete experiences with customer projects?
It's starting. It's clearly starting, and one of our most exciting projects we are delivering right now in Tatarstan, in the center of Russia, for a customer, for the customer Tatan American Investment Fund. They are running one of the largest chemical complexes out there in Russia, and they are building the largest ethylene and polyethylene plant right now. And for this plant, we are delivering a 450 megawatt combined cycle power plant, which will be able to operate at 27% of hydrogen as part of their fuel gas, which is, from our side, today in industrial use, world record. But there's more to come, and I have here in front of me, I have a burner system, and with technologies becoming available today through 3D printing, we can now shape the fuel pass and the cooling pass in these burners in a way that in our laboratories we have been running these systems now up to 100% hydrogen. And these are technologies which will come over time and which gives me the conviction that we will be able to transform our existing infrastructure in whatever the new backup fuel may look like.
And you're learning about this more and more every day, basically. So there's still a lot more to come. You just mentioned other technologies. What other technologies do you rely on besides the gas turbine when it comes to energy supplies for industrial companies?
There's a variety of products in our portfolio, and I need to look a bit that I'm not missing one.
Okay.
There's for sure gas engines, which are next to the gas turbines, and we are doing gas engines up to 2 megawatt in decentral applications, power and combined heat and power, working together with John's team very successfully in countries like UK, Brazil,
Yeah, absolutely.
coming to Germany and others. Then there's the whole range of steam turbine applications where you need mechanical drives for pumps, compressors, motors, but also converting concentrated solar power into energy, which is a leading technology in Northern African countries. China is going there with very large solar power plants where steam turbines are then the means to convert renewable energy into usable power. And then we do compression for industrial cooling and compression also for heating as heat pumps. So a whole range of varieties, and that whole thing is flanked by services for our customers, but also working with customers through our customer-facing teams like John's team in trying to find the right solution and then pick the right product out of our portfolio.
Interesting. So we're all about use cases here, of course, at Siemens. We have over 1,000 use cases on display here, by the way, on our 4,000 square meter stand. Just some numbers I'm throwing in there. Can you give us some actual examples of the use of such technologies in industrial plants?
There it becomes detailed now, and I would like to welcome Stefan on stage.
All right.
Who is leading our customer-facing decentral activities.
Stefan, nice to have you.
Nice to meet you.
Nice to have you.
So
Welcome.
Stefan, welcome.
Hi.
So Stefan is right at the center of these activities,
Thank you.
and I would like to ask him to give us some examples.
Stefan Diezinger, exactly. You want to take over right away?
Yeah, of course. So with pleasure. So first of all, to give you some figures on the magnitude. So we all talk about electricity. Industry consumes about 1/5 of the global energy. And out of this 1/5 is 2/3 is thermal energy. So it's about heat and cooling, high temperature heat, high quality heat. So this is very important.
You need the presenter? There we go.
Yeah, sure. So the first example I brought you is a traditional example out of the chemical industry. It's basically an olefin cracker producing in two processes into this production plant, polyethylene out of propane and ethylene out of ethane. Yeah? And here you can see the capacity of this plant is 2 million tons per year. And the overall heat demand is 2 megawatts thermal energy in about 135 electrical energy. And what we have done, and this is what we always do in these industrial processes, we look on this in collaboration with the customer. What is the energy demand in terms of heat and electricity? We look on the operating pattern in a consultative approach and also look on the site conditions and the regulatory framework at this specific location. And based on this, we make a tailor-made concept In this case, it's a very high efficient cogeneration application with proven gas turbine and steam turbine technology, because in chemical industry, it's very much important about reliability. You often find three parameters which are important for industry. It's reliability, it's cost of production, so the energy costs are important, and also the topics decarbonization gets more important. And this what we have brought here, what we are under preparation at the moment is, on the one hand side, we have the cogeneration facility, which is preparing the basic heat and power supply, but also we have an integrated part where the gas turbine is integrated in the process, which is used as compressor drive, as mechanical drive. And here, what we have done, we are using this gas turbine also to produce high temperature energy for the cracking process. Yeah, so this is combined. And as an add-on, I mean, as there is some hydrogen-rich exhaust gases in there, we can use this hydrogen-rich exhaust gases inside the process. And by this, we can really increase the fuel utilization, reduce the energy costs for the customer, but also get it more decarbonized, so have less CO2 emissions. And the beauty out of this gas turbine application is that the gas turbines are very good in fuel flexibility. So it provides the customer the flexibility in the future when the fuel prices might change, to also go to liquid fuels, to biofuels like biogases. And as I said, if more green hydrogen would be available, to increase the amount of hydrogen, which would further decarbonize the process. So this is basically the example out of the chemical industry. The next one is an example out of the fiber industry, which is basically 800,000 tons paper, board material. Board is very important for the e-commerce industry, which is, let's say, everybody's ordering a lot by Amazon, and this kind of packaging material is a booming industry.
Sure.
And here, I mean, the requirement was a different one. It's an existing paper production, which were fired. The steam which was needed for the process was done by a quite old, coal-fired, inefficient process. The regulation has changed in this country, and therefore it could not continue with the coal-fired boiler. So the question of the customers, I want to minimize the invest, reduce my energy cost, but also really have a emission-compliant, regulatory-compliant approach. So basically, we went also again with the customer in the process, understood the regulatory framework, the operating pattern, because it's not a completely continuous operating, and really designed something specific for his needs. I mean, we have here a solving mechanism where we really can, let's say, get all the input parameter, the boundary condition on the site, so what are the CO2 prices, what the environmental conditions, the energy prices, and then made a design where we have also a gas turbine, a high efficient gas turbine, but in a simple cycle configuration, which means we don't have a steam turbine behind, but all the energy out of the exhaust of the gas turbine is fired into a boiler, and the boiler is producing the steam for the process. This, on the one hand side, allows the customer to fulfill regulatory requirements in terms of CO2 emissions, pollutant emissions, NOx emissions. So this was the first requirement, otherwise he cannot operate. But on the other hand side, it gives him benefit that the energy costs were tremendously reduced. So this was very important.
Another great benefit.
Yeah. And the last industry, this is out of the IT industry. This is a data center. Data center, by all the cloud operations, get much more bigger. I mean, they started 5 years back, let's say, with a magnitude of 20, 30 megawatt. Now this data center get really huge because we are using so much cloud, we are using so much Amazon and Microsoft, and this data center, what I brought here, it's out of the Asian environment. Mm-hmm. This needs 75 megawatt electrical power on the other hand side for the operation of the IT infrastructure, and you need cooling. So altogether need 53 megawatt of cooling. And here we need to understood that this industry very much depends on availability. You have availability requirements more than 99%, which is, let's say, out of our industry really, really tremendous. And we had to find something, a multi-unit configuration where we use multiple gas turbines, which if somebody fails, we still can supply the required energy and also electricity and cooling. And also, let's say, can do it with a combined, highly efficient cooling and storage system. So we have an electrical compressor, and really can supply the overall efficiency of this approach was very high and could also reduce the energy costs tremendously. And as a third requirement, what we got from this industry is that we have it modular, because normally the data center people, they start with, let's say, a certain amount, and if the demand increases, they make just a copy-paste of this one, and they also want to have this energy supply in a copy-paste manner. So here it was important that we have your modular design, which could be easily expanded if the data center customer is growing.
Thank you very much, Stefan. That was very interesting, and some great examples here of how these technologies are being used in industrial plants today. Gentlemen, is there anything you'd like to add to the whole thing? I mean, what's the next big thing? Can you give us an outlook? I mean, this is all stuff that is already in place, right? You're currently working with these technologies. Anything you can look? Can you give us a look through the glass ball into the future?
I believe it's difficult to predict what the next big thing is. I think what's important is that we see technologies becoming available, be it in the modern manufacturing like 3D printing, be it in the digital space like John said, which will allow us to transform our current industrial landscape into a cleaner, a greener, and a more efficient environment going forward. And I expect this to be more an evolution. Mm-hmm. And it's starting already, so it's happening, and it will continue. It will not be the big bang in like we convert from standard phones to mobile phones, like what happened with the iPhone. That I do not foresee that for our industry. It will evolve because we talk massive infrastructure investments, and our customers are aware of that, and we talk about investments in 15, 20, 25 years. And that's important that wherever you spend your money today, you're future-proof, like Stefan was saying. And that's what we in Siemens want to stand for and work with our customers globally in transforming them together with us.
Thank you very much, Willi. And once again, it's all about saving energy, saving costs at the end of the day for the customer, which everybody benefits from. And it's good to know you have a partner like Siemens on your side who is gradually and constantly working on this topic. Thank you very much, gentlemen. I think this closes our panel here in this case. Are there any questions from the audience? Otherwise, feel free to speak to the gentleman directly afterwards. I'd like to say thank you to John, Willi,
thank you, Chris,
and Stefan.
Thank you.
And you guys have a nice day. Let's give a big round of applause. Thank you, guys.
Thank you.
Thank you.
Siemens. Ingenuity for life.